Welcome back. Today we're going to continue talking about displaying quantitative data with graphs. So, our learning targets. I can construct and interpret a histogram. I can describe the shape, center, and spread of a distribution, and I can identify major departures from the pattern. So basically today the same learning targets, except today we're dealing with histograms instead of dot plots and stem plots. So histograms are another one. It only works with quantitative data, okay? Our emphasis is all on quantitative data. All right, so histogram. So quantitative data can take many values. A graph of a distribution may be clearer if nearby values are grouped together. The most common graph of a distribution of one quantitative variable is a histogram. Okay, so this works well when you have a lot of data because it lets you clump data together. Okay, so again, here's the rules right here, but again, I'm not going to read through it verbatim because you're going to see it as we work through this example together. To make a histogram, we need to talk about classes. All right, so classes are going to be what ranges of values am I going to look for? So first of all, let's see just how much does this span. I see the smallest value looks like 50. And the largest value looks like 109. Okay, so what I'm going to do is I'm going to make my classes. Now again, you usually want only between like 5 and 6 classes. If you get more than that, or if you have any less than that, you can't see the shape. More than that, sometimes you are getting yourself too spread out. So I'm going to start from 50 up to not including 60. Okay, then I'm going to go from including 60 up to 70, including 70 up to 80, 80 to 90, 90 to 100, 100 up to 110. So notice I have to be very clear that here, if I have 60, a value of 60, I'm putting that in this category, not that one. Okay, so do you have to make sure if it's on a boundary point that you're very clear which way does it go here? If it's on the boundary point, I'm pushing it up into the next category. Okay, so now let's start counting. So between 50 and 60. So let's look to see how many of those I have. I have a 50 here. Those would work. That would work. That one. I think that's all. So I count 1, 2, 3, 4, 5. I have 5 in that class. 60 to 70. So now I'm looking at all the values in the 60s. All right, so now I count up all my green dots. 1, 2, 3, 4, 5, 6, 7, 8, 9. I count 9 in that category. 70 to 80. Oh, and I just noticed I missed one in the 60 category, so that should be 10. Now the nice thing about doing it this way is it gets obvious if you've missed one, you can just go back and add that in, which is really nice. So let's count up all my red dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, sorry. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, 80 to 90. I'm going to do those in black. Oh, and here I just noticed I missed one in the 70 category. So I'm going to go back. I'm going to up this to 11. All right. So let's go up, count all my black dots. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now I'm going to have to switch colors. So I'm going to move to yellow. All right, so now looking at 90 to 100. So there's a 99. There's 1. There's 3. 3 more. All right, so let's count up all the yellow. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then lastly, in the hundreds. So there's 1, 2, 3, 4. All right, so obviously kind of fake data. No one's working or no one is retiring at this age. However, again, some good practicing. So now I have all my classes made, okay? So now, age of retirees, I'm going to put my title. I'm going to put my age classes down here. So we're starting at 50 to 60 to 70 to 80 to 90 to 100 to 110. Notice horizontally, I don't have to start at 0. Vertically, I do though. So here's my 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And oh, 11 is going to go off my graph a little bit. So here, maybe I should count by 2s instead, since I'm running out of room. Oh. 2, 4, 6, 8, 10, 12. We'll go like that, making sure you're starting at 0. And now let's make our bars. So here, this one, from 50 to 60, goes up to 5. 60 to 70 goes up to 10. 70 to 80 goes up to 11. 80 to 90, oops, still not going high enough. 14, 16, 18 is going to be up there. Coming way up here, 18 of them. Then down to 11 again. And then down to 4. All right, so there is our histogram. Now also keep in mind that here, notice the difference between a bar graph and a histogram. Notice my bars touch here, okay? That's a key feature of a histogram, so that the bars touch, because they are a continuum of values. Okay, so do make sure that you recognize that as you're making this, you need to make sure you're making those bars touch. So that's how you would make a histogram by hand. All right, can take a little bit of work. There is a way to do this on your calculator though. Okay, now for chapter 1, since we're having to do these flexible learning days, I didn't make a separate video for this for you, so I'm just going to walk you through it in this video. So here we have some data on 30 NBA teams from the 2009 to 2010 regular season. And I want a histogram of this data. Instead of doing it by hand though, I'm going to ask my calculator to do it for me. And let me show you how to do that. So on the calculator, you turn it on and you're going to be at the home screen. Okay? All the statistical stuff that we're going to be doing, or I should say most of the statistical stuff we're going to be doing, is going to be under the stat feature. So go into stat, please. Once in stat, I want you to go into edit. This is going to let you edit lists, okay? So those 30 data points, I want you to put into list 1, okay? It's all 30 scores of those NBA teams. So I've already done it, so you don't have to sit here and just watch me do it. But I want you to go through really quickly and put all 30 of those things. If you want to pause the video to give yourself time to do that, please do. Now, once you have all 30 of those things in the calculator, if I want a histogram, I'm going to come up here to stat plot, which is right here, okay? Notice the stat plot command is in blue. So what that means, to get to it, I need to hit second y equals. And that gets me into stat plot. Okay? So I want to turn on one of my stat plots. So I'm going to enter into the first one. Okay? And I'm going to turn it on. The type of graph I want, so if I scroll down, now the type that I want is a histogram. And then notice it's already going to be pulling the data from list 1, okay? So it's going to do everything that I want it to now. However, if you just hit graph now, notice you're not really getting anything, right? Oh, and I need to go in. Okay, good, I don't have any other graphs there. All right. So notice I can't really see anything if I just go and I try to graph that, even though my plot is on. What you want to do, go to zoom, okay? Zoom, and then notice that 9th command, zoom stat, that is going to be our friend throughout this semester, okay? Whenever we're graphing things using the calculator, zoom stat will make it nicely visible for us, okay? That's going to be kind of a go-to place to shape it so you can see your graph. So this is a really cool way that if you're ever asked to make a histogram of really nasty data on the AP test, you can use this to get the general gist of it, okay? Now, the thing to keep in mind, going back to here, is if you're asked to make a graph, be sure to label and scale your axes still, okay? So don't just sketch what you see in the calculator. You still have to label it. You still have to put a title on it, scale the axes. So you still have to do all of that stuff, okay? But the nice thing is the calculator will do the brunt work for you. All right? So again, just a little tutorial on how to get the calculator to help you with all of those things. All right, what about describing the distribution of a histogram? So still quantitative data, which still means we're going to want to use the SOX philosophy, right? Whenever we're describing quantitative data, think SOX. So let's take a look at this. So the shape. Well, here I'm seeing probably what I'd call a roughly symmetric shape. I don't see it really trailing off to either side. Outliers, I'm not seeing anything that convinces me that there's outliers. Center. Center is a little bit different for a histogram versus the others. Because when you're just looking at a histogram and being asked to describe it, you can't actually see the precise center, can you? However, I can tell you which bin or which class it's in. All right, now you may be wondering, how can we possibly do that? Well, I want you to look. We know that there's 3 here, 3 here, 8 here, 10 here, 5 here, I'd say, and then 2 there. So by looking at the histogram, I know how many are in each category. So there were 31 trees as part of this data. Well, 31, awesome. That's an odd number, right? So remember, when we have an odd number of data, it's exactly the middle of that data. Well, what's exactly in the middle? Well, divide it by 2 and round up. So it would be the 16th data point. That would put 15 to the right, 15 to the left. 16th is the exact center. So now we have to figure out, well, where is the 16th data point? Okay, well, the 16th data point, well, here's 3, so here's 6, and this would take us up to 14. The 16th data point, we don't know where, but we know that it's in that class, okay, or bin, or whatever word you want to describe it. We know that it's in there, all right? So that's a difference about finding the center of a histogram, is you don't know exactly where it is, but I can tell you it's between 75 and 80 feet. Okay, that's where the center is going to be found. And the spread, it can go up to 90 feet, down to 60 feet, okay? Let's just looking at both extremes of my histogram. So once you sketch that out, again, which is what I always recommend, kind of sketch out your thoughts for socks. Now let's put it in full sentence form. The distribution of heights in cherry trees is roughly symmetric with the center between 75 and 80 feet. Its minimum value is between 65 or 60 and 65, and its maximum between 85 and 90. And there are no apparent outliers. So again, take your sketch work, and then all we're doing is turning it into full sentences for ourselves. All right, let's practice again. So cherry tree lumber, so another cherry tree example. All right, so looking at this, again, we're describing quantitative data. We need socks, shape, outlier, center, spread. So this time the shape, I definitely see it kind of trailing off to the larger numbers. So that trail is going to make it skewed right. You describe where the tail is trailing off to. Outliers, we're not sure, but there's a potential outlier between 70 and 80. We don't know, there's just the potential for one. Center. Okay, so this time, if you notice, this time we don't have counts. This time we have relative frequencies, okay? So actually that makes it even easier on us, okay? Because relative frequency just means I need to find where the 50% mark is on here, okay? Well, this represents the 30% mark. This is about 25 more. So the 50% mark to find the center, we know is in that bin, okay? So get used to manipulating things like that, seeing how can I determine center, okay? Where can I find that halfway point, whether it be counts or with relative frequencies, know how to get those values for me, okay? So here the center is between 20 to 30. And the spread is from between 70 to 80 down to between 10 and 20. Okay, once you have that scratch work, again, let's put it in full sentences. The distribution of cherry tree lumber is skewed right with a center between 20 and 30 cubic feet. Its minimum is between 10 and 20 cubic feet, and its maximum is between 70 and 80. There's a potential outlier between 70 and 80. So you're going to notice how thorough I am in my explanation, and notice I put units in my description, okay, describing the values that I'm talking about. So to wrap up, let's talk about using histograms wisely, okay? So first, don't confuse histograms and bar graphs, okay? So remember, bar graphs had gaps in between the categories. Histogram doesn't have categories. Histogram is a continuum on a number line, so they have to touch, okay? Secondly, don't use counts in frequency tables or percents in relative frequency as data, okay? So remember, that's not what you're plotting. You're grouping the stuff together. So don't just take a table and try to make a histogram out of it. It doesn't work. Use percents instead of counts on vertical axis when comparing distributions with different numbers of observations. Remember, when you're dealing with different numbers of observations, percents are more useful than counts, because obviously the one that had more observation points is going to likely have more data in each category. And just because a graph looks nice is not necessarily a meaningful display of data. So make sure whatever you're looking at, make sure it's actually just displaying what you want it to, not just that it's pretty to look at. Okay? So that is all that I have for you. Thank you for watching these, and I look forward to seeing you back in class.